Hello students, welcome to Eshwari channel. Students, in this video we are going to learn about acidity of phenol. So students, this is the structure of phenol. This is phenol and this is alcohol. So between these two, if you compare which is more acidic, whether phenol is acidic or alcohol is acidic, the answer is phenol. So phenol is more acidic when compared to that of alcohol. So what is the reason for that? So students, if you take acid, you know that it dissociates to form H plus ion and then A minus ion. So A minus ion is anion. So students, if the acid dissociates to form stable anion, if this is stable, if anion is stable, then acid becomes more acidic in nature. So same way, let us see in this two which forms more stable anion. First, let us take phenol. So phenol will form phenoxide ion. This is phenoxide ion. And let us take alcohol. Alcohol will form alkoxide ion. This is alkoxide ion. So in this, which is most stable, whether phenoxide ion is stable or alkoxide ion is stable. So students, here you can see this oxygen O minus is connected to benzene ring. So here these electrons will be delocalized by resonance. So delocalization of electron takes place due to resonance, because of which phenoxide ion becomes more stable. Whereas here this RO minus, these electrons are localized. So because of which alkoxide ion becomes unstable. So now which acid will be more stable according to this? Stable anion is formed here. Therefore, phenol will be more acidic when compared to that of alcohol. So let us see second point. This is phenoxide ion and this is phenol. Which is more stable here? Whether phenoxide ion is stable or is acidic, or phenol is acidic? The answer is phenoxide ion is more acidic in nature. So what is the reason? Let us write the resonance structures for this. So phenoxide ion, if I take first, O minus. So this negative sign will shift here. This electrons will move here. So you will get negative sign here, double bond O. This electrons will shift here. This bond will move here. So negative sign here, double bond oxygen. Then move these electrons. So this is what you will get. This is resonance structure for phenoxide ion. Next we'll write for phenol. OH. On oxygen, two lone pair of electrons will be present. So shift one lone pair of electron here and this will move here. So you will get double bond OH, positive sign on oxygen and here negative sign. Move this here and this electrons here. Negative sign here. So again negative sign move here, this one here. Double bond OH, positive sign. So again negative sign here and then this bond here. So finally you will be getting phenol. So students, if you compare the resonance structures of phenoxide with that of the phenol, here you can see positive sign, negative sign, positive sign, negative sign, positive and negative. So there is separation of charges in the phenol. So in phenol you can see separation of charge. Separation of charges, whereas in phenoxide ion you cannot see any separation of charges, it has only negative sign. So therefore if separation of charges is present in the resonance structure, then it becomes unstable. Therefore phenol is less acidic when compared to that of phenoxide ion. So this is second point. Third point, so this is phenol, and to the phenol we have attached electron withdrawing group. It can be at ortho position, meta position or para position. And to the phenol attach electron releasing group at ortho, meta and para position. So if you compare the acidic strength, so here phenol to which electron withdrawing group is attached will be more acidic when compared to phenol, and phenol in turn will be more acidic when compared to this structure where electron releasing group is attached to phenol. So now let us use this in this example. So in this example let us find out which is more acidic in nature. So students, this is phenol to which Cl is attached. So Cl group will show minus I effect. So minus I effect. So minus I is nothing but electron withdrawing group. Electron withdrawing group. So electron withdrawing group, if it is present, it will be more acidic than phenol. So here phenol is there. So here you can see electron withdrawing group in all the three structures. Therefore all these three will be more acidic than phenol. So phenol will be last. So let us compare among this which is more acidic in nature. So you know students, inductive effect depends on distance. So near the distance the effect will be more. So here Cl at the ortho position is very close by. Therefore because of inductive effect this is very close by. Therefore you can see this is found to be more acidic in nature. Second is this, and third is this, and fourth is this. Next, fourth one. So students, you can see here phenol. To the phenol we have attached fluorine, and here to the phenol we have attached chloro group. So if fluoro and chloro group where it is attached, so this position we call it as ortho position, this position we call it as meta position, and this position we call it as para position. So F is attached at para position and here Cl is attached at para position. If F and Cl is present at equal position, so here what is the position? Position is para. So both are present at the para position. So if they are present at equal position, then always chloro will be. So here this will be more acidic when compared to this. So what is the reason for this? The reason for this is because of d orbital resonance. This is due to d orbital resonance. So what is that d orbital resonances? In chloro group you know that there is d orbital, whereas in fluorine there is no d orbital. So therefore in d orbital resonance can take place, because of which the number of resonance structure in this structure it will be more when compared to this structure. So let us write and see the resonance structures. So first let us write the resonance structure for this one. OH, and here F is attached. So let us write the resonance structure for this one. So here lone pair of electrons are present. So this will move here and this is going to shift here. So you will be getting negative sign here, then F. So negative sign will shift and this will move here. So negative sign here, F. This negative electrons will shift here, shift this bond. Sorry, this becomes here and here negative sign. Finally shift this and then this bond. So you will be getting. So count how many resonance structures are there here. So totally 1, 2, 3, 4, 5. So totally there are 5 RS. RS is resonance structures. So we'll see for this to the phenol if chloro group is attached. So now lone pair of electrons are present here. So this will shift. Double bond O and this negative sign here and positive sign here and then chlorine. Electrons shift here, then this bond shifts here. So you will be getting negative sign here. Negative sign shifts here, bond shifts here. Shift this negative sign here and then bond. So now students, chlorine will be having d orbital. Because of this, one more extra resonance structure you will get. So one more resonance structure you can write for this is, this negative sign can also shift here. So you will be getting and here double bond Cl negative sign. So this is one extra structure you will get for get if chlorine is attached to phenol. So this is 1, this is 2, this is 3, this is 4, this is 5 and this is 6. So totally 6 resonance structures you are getting. So here more the number of resonance structure, more the stable the ion will be and it will be more acidic in nature. Therefore, whenever fluoro and chloro groups are present at equal position, always chloro attached to phenol will be more acidic in nature. So this is 4th point. So next we'll go for the last one. So students, will take these two structures. So here there is no ortho effect in phenol. So already in last class I taught you ortho effect in acids. So usually ortho effect is seen, that is if a group is present at the ortho position. For example, we'll take acid COOH. If a group is present at the ortho position, so this is the group at the ortho position. So if a group is present at the ortho position, then what happens is the plane of this acid will change. So when the plane changes, what happens is it can easily lose this proton. So this goes out of plane when a group is present at ortho position. This is what happens in acid. But here there is no ortho effect in phenol. So in phenol, if a group is present at the ortho position, it doesn't show this effect. So now in these two structures, we have to see which is more acidic in nature. So students, here NO2, what kind of effect NO2 will show? Between nitrogen and oxygen, double bond is present, therefore it will show minus M effect. So already I taught you how to find plus M effect and minus M effect. So students, if you don't know, you can watch my previous video on mesomeric effect. So I have taught you the trick how to find out minus M effect and plus M effect. Which groups will show minus M and plus M effect. So NO2 will show minus M effect and then minus I effect, because between carbon and nitrogen, nitrogen is more electronegative in nature. If it is more electronegative, it will be showing minus I effect. So here also nitrogen will be showing minus M effect and minus I effect. But here what is one difference is, so here adjacent to nitro group you can see two methyl groups are present. Because of this bulky groups, steric effect happens, due to which this goes out of plane. NO2 group goes out of plane. So it goes out of plane. So when NO2 goes out of plane, this effect is not felt. So this effect is not felt on phenol. Therefore, we have to consider only the effect of methyl group. So what is the effect shown by methyl group? Methyl group will be showing plus I effect. And here minus M and minus I effect. So now which is more acidic in nature? So students, just now we saw, see here, if electron withdrawing group is present, it will be more acidic. So here minus M is nothing but electron withdrawing group. So electron withdrawing group is present, therefore this will be more acidic in nature, whereas here plus I is nothing but electron releasing group it is. So therefore this structure, so structure 1 and this is structure 2. So structure 1 will be more acidic when compared to structure 2. So here what happens is the effect of NO2 is not felt because it goes out of plane, because two methyl groups are present, which is bulky groups adjacent to nitro group, which makes nitro group to go out of plane. So this is the reason. So students, I'll meet you in the next video.